So I would like to introduce now our panelists. We have here Julie Klinger. Julie holds a PhD in geography from the University of California, Berkeley. She is an assistant professor in the Department of Geography and Spatial Sciences at the University of Delaware, and she is an associate director of the Minerals, Materials, and Society program, focusing on the dynamics of global resource frontiers and space-based technologies, with particular emphasis on China, Brazil, and the US. Dr. Klinger has conducted extensive ethnographic, qualitative, and quantitative fieldwork over the last 15 years. She has written articles on rare earth elements, natural resource use, environmental policies, and so on. Her 2017 book, which I highly recommend, is Rare Earth Frontiers from Terrestrial Subsoils to Lunar Landscapes. And it was awarded the Meridian Book Prize for its unusually important contribution to the art and science of geography. Dr. Klinger's global research agenda consists of 3 distinct yet interlinked initiatives: critical mineral supply chain, global space politics, and rural and indigenous community survival strategies. I could go on and on, but I think this is quite a mouthful. We then have Gareth. Gareth is the co-founder, CEO, and chairman of Innovation Metals Corporation, IMC, which is now a wholly owned subsidiary of Ucore Rare Metals Incorporated. Gareth is the co-inventor of IMC's proprietary Rapid SX separation and purification process for rare earths for critical green energy metals such as rare earth elements, lithium, nickel, and cobalt. He is also managing director of Strategic Metals Advisors and was a co-founder of Technology Metals Research, consulting firms operating in the critical materials sector. Through these roles, Gareth has led cutting-edge R&D work and has advised public and private companies, institutional investors, and government aid entities on the threats to the strategic materials supply chain. He was previously interim CEO and director of Alabama Graphite and director of technology at Dexter Magnetic Technologies, where he started his career and focused on rare earth element permanent magnet design and engineering. We then have Carlo Bulka. Carlo Bulka is the professor of manufacturing technology, head of the Institute for Strategic Technology and Precious Metals, STI, at the Pforzheim University in Germany. He is also the coordinator of the European project SUSMAG Pro. The project aims to develop a recycling supply chain for rare earth magnets in the European Union and to demonstrate the effective reuse of recycled rare earth materials within several industries. Previously, for 6 years, he has worked as a technical managing director at OBE Ohnmacht and Baumgärtner GmbH in Ispringen, Germany, still working there as in an advisory capacity responsible for technology and innovation. He obtained his doctorate in metallurgy and materials from the University of Birmingham in 1996. He's the author of 3 textbooks, more than 20 peer-reviewed papers, and is the holder of several patents. Then we have Peter. Peter Pionee is the executive vice president at Urban Mining Company in Texas. He has been in the materials industry for more than 15 years. He has focused on rare earth permanent magnet materials for the last 10 years. Peter and his team at Urban Mining Company have played a pivotal role in re-establishing neodymium magnet manufacturing back in the United States. He is actively involved in building up an upstream supply chain, not only to support his business, but also serving the broader US domestic rare earth market. In addition to his executive role at Urban Mining Company, he's also a senior advisor to the US Department of Energy's Critical Materials Institute. Welcome you all. About myself, I've been a director of the small company GITI in Singapore since 2016. This is a trade and investment consulting company specialized in rare earths and steel. Prior to this, I worked at several top management positions of leading German, US, and Swiss petrochemical steel companies in Asia, primarily in China and in Japan. I served as the chairman of the Metal and Mining Working Group of the EU Chamber of Commerce and of the EU Executive Training Program in Japan. Right. So we have heard two fantastic presentations in great detail about the current situation and the forecast situation in rare earth and rare earth magnets. And I would like to start with you, Peter. How would you see the current supply chain for rare earth and magnets within the United States?
At its infancy, I think is a good way to put it. There's quite a bit of demand that's being driven in the market that we see within the U.S. industry. I think that there is a need for a developed supply chain in the United States and in North America more broadly speaking. The biggest challenge, I think, when you talk about rare earth production in the United States is really in the intermediary processes. So I think in metallization is a big component of that. So I think, you know, it's at its early stages. There's tremendous amount of interest from a governmental perspective, from an industrial perspective, to drive sort of the growth in that industry, but there needs to be a lot done from a technological standpoint to support any materials that are ultimately going to be refined within the United States by companies like MP, Ucore, and so on. So yeah, I would say it's at its early stages and it's growing.
Okay, excellent. Gareth, do we have, you are an inventor and an accomplished researcher into processing of rare earth. Do we have everything we need to process rare earths outside of China?
Great question. So I think we do. I think from a from a process development, technology development perspective, the potential is there. I would say it's a bit of a truism. It's often discussed at events like this. From a people point of view, there's certainly a strong need for more expertise, the growth and development of early career engineers, technicians, and all of that. Often the number of technical people in China is mentioned, and it is very significant. And I think there are some very fine scientists and engineers in China. So that's certainly one aspect of this sector and many sectors that frankly are relying on places other than North America or Europe or whatever. It's very much part of the equation. Those that are present are working hard, both in academia, both in industry, and also helping policymakers to understand what's going on and what's required. So I think from a technology or technological point of view, the pieces are there, not just in terms of the separation and to an extent, as Peter alluded to, metallization and the downstream, but also in the extractive metallurgy side of things, that part of the supply chain between mining material out of the ground and producing, let's say, concentrates that can then be purified. I've certainly seen a lot of good established work and newer, innovative methods of doing things. So the potential is there. It's now a case of executing and getting into kinetic mode.
Okay. Carlo, how does it look in Europe in terms of supply chain? We're making a lot of efforts into recycling, but do we have enough material that can be recycled?
No, currently we don't have enough material that can be recycled for a certain number of reasons. The first one is obviously that there's a 14 to 19 years delay in the applications that we've seen with wind turbines. We're talking about a life endurance of roughly 20 years. With a car, it would be 10 to 14 years, really, if we wouldn't export the cars, what we are currently doing to third countries. So assuming that electrical cars would stay in the market, it's still a 10 years gap with increasing numbers, obviously. And there's another thing, apart from where I agree absolutely with Gareth, that we don't have the knowledge. Well, we have the knowledge, but we don't have the workforce to execute it, and we need to educate more people in the subject. The other thing that we see is more and more an issue. It's not the recycling of the magnet itself. Once you have it on the table, it's very simple, but it's a segregation to take it out of the component. And we see that a lot of products are not designed for recycling. So we struggle with coatings, we struggle with glue, we struggle with accessibility itself. And that makes it a very tough business to be profitable. Of course, it can be profitable, but there are some applications like the wind turbine, which everybody is targeting because the magnets are there in large quantities. They're relatively easy accessible, still depending on the geometry or the design of the windmill. But overall, if you look in electronic scrap, for example, it's extremely complicated to be profitable. And if in our product, we do the silly thing to detect, first of all, what kind of magnet is inside. Is it ferrite? Is it samarium cobalt? Is it bonded? Is it sintered? So we have no marking, we have no labeling, which would facilitate this.
So basically, for the foreseeable future, for a number of reasons that you mentioned, we may still largely depend on China to supply us magnets and some of the rare earth products that we need.
Yes, I mean, we have to enforce secondary material, definitely, because of the carbon footprint. But the quantities they're just not here. So we're talking about thousands of tons and not 10,000s or 100,000s of tons of material.
Yeah. So, Julie, now your expertise is absolutely necessary, because if we talk about resilience of the supply chain, we have nascent supply chains in the US, we have a lot of concepts in the EU, but all of this will not get going in time for the predicted explosion of demand, even if it comes in at much lower numbers than projected. Can China be trusted?
Oh, that's a very interesting question. Well, I think all of the geopolitically charged rhetoric aside, the fact that China is really important for our global rare earth supply chain also is another way of saying that China's rare earth supply chain is globally interdependent. And so even though different countries, and I'm speaking from the US perspective, where as Gaius previously noted, I mean, there's a 70% import dependence averaged across the different rare earth elements within the US market in particular. This is the result of several decades of global economic integration. And so if you put aside the fears that are useful maybe for scoring political points with specific constituencies and actually look at the deep, rich interdependence among firms and also researchers, I think that the simple question is that it's in China's interests, and it's in China's interest because it's in everyone's interest that the global supply chain remain reliable. But that only addresses one dimension of supply chain resilience, right? Which is this question of possible economic statecraft or geopolitical posturing. We have heard a lot about the projected demand increases, which are given particular urgency in light of our current climate crisis. And there are, of course, bottlenecks that we're running into as different stakeholders around the world scramble to bring new sources online. But we do also need to be mindful of the ongoing supply chain impacts that are resulting from the unpredictable outcomes of the continued burn of the COVID-19 pandemic. So we have situations where, like Leslie noted, there are borders that are being closed, although I do have some questions as to whether that's overland versus maritime borders and things like this. But we do also have labor shortages at major ports, and shipping industries are undertaking cost-saving measures. That means that even when materials are ready to be delivered to market, they aren't necessarily getting to where they need to go. And so I think the unifying thing here in your question, but in these broader dimensions of supply chain resiliency that we need to be mindful of, is how can we effectively deal with this uncertainty? I don't want to monopolize the time. I have some ideas on that, so I'll let you do another round and maybe offer some of those in the next round.
All right, thank you very much. So, Peter, Carlo described some troubles with the recycling of rare earth magnets. Your company basically recycles magnet to magnet. Is that correct?
That's correct.
So you were not quite clear about how you do this, but do you face these problems when?
You kind of cut out there, Thomas, but I think I understand where you went with the question. Yeah, I mean, I don't see the numbers, the same numbers that Carlos is reporting, where he's saying thousands of tons of scrap is available versus tens or even hundreds of thousands. I'll provide a very specific example. If you look at a hybrid electric vehicle traction drive motor, and I think the first one was introduced in '98, each hybrid electric vehicle traction drive motor contains about 1.2 kilos of magnet. And if you look at the US sales figures alone and factor in even a 15-year life cycle for such a motor, there are tens of thousands of tons available just from a single producer, single model of that vehicle. I think that the challenge tied to recycling or procuring end-of-life materials is not only on the OEM side, which is tied to a lot of the things that I agree with Carlos's statement, which is there isn't a uniform sort of assembly or disassembly process. There is no traceability, there is no marking, and therefore that presents a lot of challenges from an extraction perspective, and that absolutely needs to be a stakeholder process where you get public and private organizations involved to establish a standard to do that at the OEM level, so that it makes it easier to recover the material. So we're in agreement there. However, on the other side of that coin, I think, is the technological aspect, right? And so it's a limitation of technology, really, and it's not only limitation in terms of extraction and separation, but also what is the value add that you're bringing in on the recovery side, right? Are you recovering for rare earth oxide? Are you recovering for some sort of concentrate? Are you recovering for a metal? And then what are the process? Are you recovering, in our case, for a magnet, right? Are you only recovering the rare earth elements, or are you recovering all 17, 18 elements that are part of that microstructure, which makes up a magnet? And when you take that into consideration, I believe that there's also an economic justification for mobilizing an existing recycling infrastructure to incentivize that existing recycling infrastructure to introduce valves, so to speak, to extract the material that is needed in the way that you need it for downstream processing. I think I'll leave it at that.
Okay. Gareth, in terms of process, I think in China, when they do recycling of swarf and magnet scrap, they use standard solvent extraction process, right? So would your process also work for recycling in the West? Say, if you were to start from a powder made from some magnets?
Yes, it would. I mean, solvent extraction as a chemistry or a chemical route for processing is well established. It's a fairly robust approach, and really the question is about I suppose if you think about it from the big picture point of view, are there from a resource utilization point of view, are there more responsible ways of using those materials? And so if you have the ability to do, for example, magnet to magnet or downstream conversion, then it would make sense to do so. There are always going to be materials that are not suitable, perhaps they're in a corroded or degraded state or other parameters where, particularly with the acidic nature of solvent extraction, that's a lot more forgiving. I will say that it's my understanding that certainly if the origin of the scrap at the magnet factories and so on is in a controlled environment, then that can even be put into the pyrometallurgical stage, the melting stage. So, but yes, I mean, there are a number of technologies that are being evaluated and being developed. Selectivity when it comes to rare earths, the key criteria or a key criteria is the ability to selectively extract or to separate particular elements, and there's been a lot of work on that, and doing so in a manner, of course, that's both economic, but there's also quite a bit of scrutiny and research now on the LCA or the CO2 footprint side of things as well. So I think there's also some really quite interesting work going on to improve the tried and true steps of things like precipitation or calcining and so on, that can also make a contribution to to the efforts that we're talking about.
Right, Carlo, may I ask, when the result of recycling these products, how are they priced compared to the virgin new product that comes out of the Chinese factory in terms of price? Cost?
Well, that's an extremely complex question that you're asking, because as we both pointed out, there are different recycling processes, and there are a lot of different states how a magnet can be in, and there are also different scenarios where one of the recycling method may be extremely productive and cost efficient, and on the other one not. For example, if you look in the direct recycling that was mentioned by Peter, it could be that you have some coatings that you cannot separate from your magnetic powder that would increase your carbon level to where you cannot use the material anymore, and then here the hydrometallurgy would have been a much better route. Or you have to remove the coating before, so additional processes like the segregation. So I think the key is the combination of all these, and to exactly map and find out which is the best recycling method for the respective product. And of course, if we could have marking and labeling, it would be simpler. I mean, I could make you a scenario where I can recover an alloy to directly make a magnet for 10 euros. I can make you another one where I can extract it and recover it for 150, because the accessibility to the magnet takes an hour until you're there. So it's not a black and white thing, but for a certain, and that's where we differ in the number. I agree that so many tons are here, as Peter said, but I was filtering already for the ones that can be that can be recovered in a commercial viable way, and that reduces the number dramatically right now. But it must not be like this if you would have some design for recycling measures in place. But we have to bring this to the OEMs. We have to educate people with that. That's of course one of the challenges and the duties that we have as academics. And I think in 5 years we probably talk differently about the things like now. So that was
Carlo,
a very political answer. Yeah.
Yes, you wrote a paper about the need to mark magnets according to their chemical content. Have you ever been in touch with peers in China to suggest it?
I mean, we want to bring this into the standardization committee, but of course the approach we have currently is a quite naive one, I must say, because nobody will write a chemical composition on the outside of a product. So we have to integrate this into blockchains, that IP is protected, and yes. So it's again a complex matter to say we have to label it on the outside, but we have to come to some minimum standards that allow automatic sorting. That would be the key for a lot of things. And even a simple one like it's samarium, cobalt, or fluoride, or neodymium boron, which help immensely to separate the value streams.
Julie, stand up. That is your subject. Where are we with rare earth standards? I understand there has been an initiative for about 6 years, I believe, to take Chinese industrial standards and adapt it in the West so that we are basically universally the same standards. How are we doing that?
Well, it's a little bit more of a, I was going to say two-way, but it's more of a multi-way traffic and negotiation over how the standards are being defined. And so the first thing I'll say or confess is that, you know, when you have a hammer, everything looks like a nail, and the particular hammer that I'm wielding these days in my public service work is around standards development. So, you know, the challenges that are being discussed here, I'm thinking, gosh, well, that's a problem with a standardization solution. And so along the lines of standards development, I think it's actually quite encouraging, because this is where international collaboration is happening. There's the peer-to-peer industry level standards that of course is occurring through REIA and its partner industries. And then there's the intergovernmental cooperation that's occurring through the International Standards Organization. And I can speak with more knowledge to that. Now, the work that's unfolding in the International Standards Organization is not yet at the level of detail to provide standardized specifications for magnets or specific components or things like that that would actually facilitate recycling. We're not there yet. I think it's going to be a couple of years. Currently, where we're at is developing standards around transparency and traceability in the upper portion of the supply chain. So from the process of digging the stuff out of the ground to the point where you have refined oxides that are then sold to various downstream users. And there's also taking into account the possibility for recycling and reclaiming secondary materials within this portion of the supply chain as well. A very early effort is underway in order to develop ISO standards for sustainability, environmental and labor and social sustainability within the rare earth sector. And so this is very unglamorous work. You know, it takes place in small rooms tucked away in the corners of buildings, or, you know, in these eras alone, we're all alone in our offices, poring over documents and conferring with stakeholders in our respective constituencies. It's a gradual process, but I do think that it is, you know, also to kind of reference your initial question, Thomas, it is the sort of proof that international collaboration to get past these uncertainties, to develop standards so that then the specifications are set, so that then there is actually some certainty for all different actors in the supply chain. Like, the hard work is happening. It just doesn't necessarily catch the headlines in quite the same way.
I'll add to that if I may, Thomas. Two points, and I echo what Julie said. I know she's involved in the ISO standards. I've been involved both through the Canadian group and more recently through the UK. A couple of points which are relevant to all of the ISO standards, but particularly for rare earths. Certainly, I think the impetus did come from China in terms of approaching ISO and putting standards into an international format and so on. But China is by no means the only voice. It's, from my observations, it's a pretty democratic process in terms of voting on taking documents and drafts and iterations and so on forward. That sort of round robin collegial approach does mean it takes a bit of time to get through some of these things. But that's okay. Some of the earlier standards, in addition to the ones that Julie mentioned, also revolved around some very, I would say, esoteric or specific methods of doing measurements and things like that. And I think that was a first foray from our friends in China to sort of introduce what they've developed and what they've learned into the process and get it going. But it's it's been an interesting process. And there's also at the national committee levels, stakeholders both from research and academia, but also very much from industry as well, and end users. Canada in particular is pretty strong in that regard, as are a number of other groups. So voices are being heard, input is being given, and it might take a little bit longer before we see a plethora of these standards, but it is coming.
I think it's worth to maybe mention and have a little conversation about it. And I will, especially from you, Julie, I kind of would want to know what the perspective is on the magnet side. What I see from a market perspective is that even if you take grades of magnets, of neomagnets that are generally known and that was originally established by the Japanese and been full-heartedly adopted by the Chinese. If you take, a basic N42 SH type magnet or an N40 SH type magnet, and you procure it from 5 different suppliers, you're going to get 5 different magnets that behave very differently. So I think that's a challenge. I also think the challenge is on the end user side, regardless of the nomenclature that's used by a producer. Because when a magnet is manufactured, it's done so very specifically to an application's requirements, and those applications vary even within the same industry or vertical that you operate in, right? So a GE Renewable Energy and a Siemens Gamesa, for example, both are producing a wind turbine. Both will require magnets for their direct drive wind turbines, and maybe they'll even require the same grade, so to speak. But the behaviors and the operating conditions that they establish for their motor, for their drive, may be different. So we always approach the issue or the market really with the perspective of magnets being an engineered product, not off-the-shelf commodities, which I think a lot of people tend to misinterpret them for, right? I mean, it really is not a commodity, so to speak. So yeah, I'm just curious to know how you see that being addressed.
Yeah, thank you for introducing this additional nuance specifically with respect to magnets. I think so. My personal analysis here is that if we wait for the standards development around magnets in particular in order to facilitate recycling, easier recycling practices and things like this, if we wait for that to occur through a process like the ISO, we're going to be waiting for a really long time. I think what I would like to see happen is a sort of incremental approach to gradually address some of the major issues that have been raised by you and Carlo just in today's conversation. So an example would be, let's develop some basic standards around the coatings, for example. Standards are, they're common throughout the economy. I mean, there's very specific limits about how much dairy you can have in a product, or whether or not it's called cheese, and so on. And so I think that we can take a sort of similar approach to different small pieces that are posing currently these outsized problems to the development of the magnet recycling industry. The other thing that I want to pile on here, and this is again underscoring my point that I think that we do need to be proactive and take action at the national and subnational level as well, and that then can later drive international standards development, is around the problem of putting the social infrastructure in place to actually pull these things out of people's attics and waste dumps and things like this, and to get them to centralized facilities where they can actually be processed. And I raise this specifically in response to the point that Carlo made, which is that sure, recycling eventually might make a significant contribution to offsetting our supply and demand constraints, but we do have to bear in mind that first we're going to have the demand spike, and then those elements are going to be locked up in those products for hopefully what is an extended life cycle. And that means then effectively that those resources won't be available for recycling. I think that actually we might also want to look at what our current above ground assets might be that are currently languishing in different forms, whether it's in electronic waste that either has or hasn't been collected, and also especially in defunct mining sites where you have above ground resources of minimally processed material that might be rich in rare earths and other critical materials that is currently existing as an expensive environmental management problem. Right, and so I think if we bring all of these to bear together, then that takes a little bit of the heat off of, say, GE or other private companies that are producing these engineered products to just disclose their formulas as, the key that we need in order to unlock all of this. We'll get there, but I think if we bring a bunch of other elements to bear as well, that we're more likely to make progress with these particularly sensitive things around IP and what have you.
I would like to add here, Peter, you said magnets are an engineered product. I agree completely, and I don't agree on the other side, because we've seen when we went over the market and analyzed coatings that these coatings, for example, they are kind of random. And they could be that one manufacturer has spray coating, the other has electroplating, and this is how it's done. And here the OEMs, they specify just the corrosion resistance. They don't specify a coating, and they're not aware of the issue that it could cause with the recycling. And the other thing is that the marking is ticking completely different, like, for example, the steel industry. That's what you mentioned. There's an N42SH is different all the time. In the steel industry, you have a 316L, which is a chemical composition, and the end user doesn't care how much of recycled amount is in. But with the magnet, it's a specific composition that defines a specific application then, and it may be even traceable down to the mine where the magnet is coming from. And so this is an extreme challenge for the recycling that we have to address somehow. And here we're working on ideas But I think, as you said, the market is developing, and we have to do our homework right now, that we can address the recycling of the things that come back in a couple of years more effectively, to bring it really back into the loop, because a lot of it is now in landfills, and as you said, also these mining tailings that are existing. There are immense amount, which is also kind of recycling for me. So we have to get the mixture right, I think.
Yeah, I mean, I guess I'm coming from a perspective where, you know, we've commercialized a technology that has kind of addressed the composition issue. The variability in composition is not so much an issue as it relates to us processing the material into a new magnet. So I don't, I think that might be where kind of the difference of opinion exists when it comes to how we actually go about procuring these materials. But I do have to say that, yeah, you're right. I mean, I think that like something like coating is quite arbitrary, right? It's easy to kind of convince a buyer of magnetic material to kind of go with your technology, whatever that may be. Yeah, that's it's a fair point.
Question maybe for Julie, Carlo, or Gareth. You see, as far as we hear from China, they are also extremely interested in traceability. For example, the Ministry of Industry in Beijing has a plan to introduce blockchain traceability in rare earth. So I really wonder if all these activities are somehow coordinated, somehow in tune. Is there any, say, political agreement or any agreement on peer levels to cooperate on that? Julie?
So I'll defer the specific question around peer level coordination and speak to the policy, the broader policy impetus for this. So there is among folks who are working in this space, particularly around transparency, there's an assumption that the kinds of regulations that we've seen developed either via in the US Dodd-Frank Section 1502 or the OECD legislation around conflict minerals, which then, you know, is EU-wide, but then EU member states have their own specific regulations around these things. There's a sense that similar sorts of requirements will be progressively applied to things that are classified as critical materials, right, rare earths included. And so a lot of the energy around this transparency work is an attempt to get ahead of that. Because certainly what suppliers in different parts of the world want to avoid is a situation where, for example, and I'm just being hypothetical here, hypothetically, you know, the German government introduces some legislation or issues a temporary moratorium on importing elements that might, or products that might contain elements that were sourced from a place that uses child labor, or where you've had a recent military coup or human rights violations or things like this. And the suppliers in China and elsewhere will need a way to demonstrate that the products that they are supplying are separate from the inputs that might be coming from more problematic sources. I'll stop there.
So in other words, we are not really talking. You see, I see a certain risk here, and that is, how did we get here to the dependence on Chinese magnets? We got there because in China it has been a policy to try and add value to rare earths, which as such, just selling them abroad to Japan or somewhere did not really add value. So China devised policies and took measures in order to add value, among other ways, making NdFeB magnets. And as we've seen, they are building up a fabulous capacity, which will easily cover world demand, in my opinion. So the risk here is that China says, okay, if you make it too complicated for my magnets, I go even further downstream. I don't sell the magnets to you anymore. I build up an industry, a car industry, a wind tower industry that is big enough to consume everything that I produce. And in that respect, I'm kind of, I feel there is a certain disconnect that we have to enable them by communication. I mean, we have to tell them what we plan, they have to tell us what they plan, and we have to find a way that is mutually acceptable, and that guarantees that Chinese products can still be exported, because we may over-regulate ourselves to the point that the Chinese say we will not comply, yeah? And that we will not have a total funneling of everything into Chinese downstream industry, which is eventually also against their own interests. But I'm missing the element of communication, and that is why I kept asking you guys talking. No? Yeah. So
yes. I just want to say very quickly that the perspective that I put forth and the strategic hypothetical that you put forth, I mean, these are both very present elements of the debate. There's a lot of conflicting ideas about what to do and how to manage things going forward. We know this from our own respective national contexts, and the same also applies to the Chinese context as well. Carlo, you were going to say something?
Yeah, I wanted to say we have a blockchain already in place, which is we have bits and pieces stored everywhere, but we just don't have the linkage right now. And I couldn't agree more with what you said, Thomas, that we have to make it feasible, but not too complicated. And I think that's a challenge. And that's why, for example, we don't stick our head out currently. We try to come to solutions that are kind of feasible to have a proposal. And I think that that's necessary, that you understand the process good enough, which we don't right now, I must admit. And you can come up with a comprehensive solution that's then working for everybody. For the suppliers, for the OEMs, there are IP issues involved. There are a lot of other political things to regard here, which make it very easy to ask for a marking and a labeling, but to bring it into place and also to judge what is resilient, what is sustainable, what is ethical. In itself, you need to find a model that really is feasible. But on the other hand, what makes me a bit optimistic here is that it's not the rare earths alone that are facing these issues. We have a lot of products like that. In Germany, first reflex when talking about ethical supply chains, it's always the clothing. They always illustrate it with the clothing. And so a lot of industries are thinking the same way, and we have to bring these efforts together. And I think that also makes trade negotiations much easier.
Just a brief comment. I think it is important to recognize, and I've used the term off and on over the years, that the West, Europe, North America, essentially outsourced the production of magnets to China on the basis of a lowest cost at any cost approach, very much driven by commerce and everything, without really thinking about the big picture. That's not unique to magnets, of course, but it strikes me that at the moment we're in an interesting situation where clearly the magnet industry is dominated by China. That can change, particularly if processes are brought to bear and materials are produced in a competitive manner. And all of that, but also because, as Leslie's presentation indicated, countries like Myanmar, even the US, from an upstream sourcing of materials point of view, is increasingly becoming important to the Chinese. And so one could argue, okay, well, at any moment they can simply stop importing those materials and they'll just reopen mines and so on. And I don't think it's as easy as that now as it would have been, say, 20 or 30 years ago. So there is some leverage here, depending on where in the supply chain or the nodes in the supply chain you're looking at, to affect some change. So it's an interesting time and an interesting topic on this blockchain stuff, because you know, nobody wants to add cost to their production, but if there is this interdependency between suppliers and buyers, then, as you say, people are going to start talking to each other. And I think it is happening, but it needs to be accelerated.
China will be more dependent on rare earth raw material supplies from abroad. And I think a glowing example of that is MT Materials, because it was China who financed the restart of the mine, made large advance payments to MT so that they could operate and ship the product to China. And in the current political environment, it is not possible for China to replicate that in Australia or in Canada, simply because the political relations are not favorable for investment, and especially not investment of that scale. And as we have seen from Gareth's presentation, there are no investment banks researching the rare earth sector. Yeah, so there are no investors coming forward to finance a large rare earth mine startup. So my question to you all is, in an absolute ideal development, would you think that we will be in time to have enough materials and finished products according to the schedules that we set for the global warming agenda?
The question is how ideal you will make the environment. I mean, in Germany, we need 30 years to build a train station.
You see, this whole drama with rare earth magnets, why do we have it? We have it because we have to replace fossil fuels and quickly bring down our carbon dioxide output. And the way things are going, some development in the West, some development in China, gaping supply holes are opening on all sides, whatever it may be. Yeah, then we really have to question, are we getting anywhere?
I would put it a bit differently. I think wherever there's a market, we are always reacting fast. And if we look at the numbers of Gareth, as he has shown, I mean, this will increase the momentum in investments, and this will speed up legislation. And so, well, I'm convinced that there will come to solutions because the market forces are developing it here. Otherwise, well, I'm a bit disillusioned if you look and you know how to make the world better with legislation and framework conditions and so on. I think, but the market will follow here. So I see it a bit, yeah, optimistic from that side, that the market will regulate it.
Yeah, I agree with Carlos's sentiment there. I think that the market is responding. Even with a globalization pause and reversal that started way back in 2008, you know, organizations, industry are responding very, very aggressively to that, and they're shifting their supply chains, whether it's for magnets or rare earth material based products, or things like copper or lithium-ion batteries or whatever it may be. They're shifting their supply chain so that they can diversify and respond to some of the centralization, I guess, and the risk associated with what happened when, you know, as Gareth mentioned, you know, the West really kind of approached this low cost at any cost approach. And so, yeah, but I'm optimistic. I think that the market will respond. It would be nice if you could incorporate a little bit of the EU sort of like legislative efforts that are being put forth in North America as well. I think that there is a lot of good that's happening in North America with some funding behind the Department of Energy and the Department of Defense. But there, and recently some tax bills have been introduced that could potentially incentivize that market even further. But I think a lot more has to be done on the sort of stakeholder, like producer take back responsibility kind of perspective. And I think that, a lot of legislative efforts from a U.S. perspective, like within the Office of Waste or generally the EPA, can help support that effort to mitigate some of the demand risk associated with the growth in the industry. Because Thomas, like you're mentioning, yeah, if we're going to shift into sort of this more electrified future as we talk about it, it's really necessary in order to kind of hit the decarbonization targets or the neutrality targets that are set in motion by just general public consensus.
I'd like to answer that question in a sort of similar manner that I addressed the supply chain resiliency question, which it's because we're talking about this in the context of climate goals. The thing that we really must take into consideration is that our processes of acquiring additional materials don't have the effect of increasing our greenhouse gas emissions. And this occurs through direct ways, in terms of, additional fossil fuel combustion in order to build out these supply chains and all of this. But it also occurs in indirect ways, particularly where landscapes and livelihoods that are low carbon or actually serve a really important carbon sequestration ecosystem service provision purpose, where these are directly undermined by efforts to open up new mines or things like this. And so this is particularly why my focus is on, how do we actually tap these other secondary sources and scale that, and what are the sort of legislative guardrails we need to put in place in order to make sure that that becomes a more viable option. Because currently, and I think deeply paradoxically, our path of least resistance appears to be, let's open more mines. And yes, we're going to need to open more mines, just simply to meet our raw materials needs. But that as the go-to option, I think may have the effect of undermining our overall objective of decarbonizing our economy in order to reduce the total number of emissions that we're releasing into the atmosphere.
Right. Gareth, you're so quiet. What is your opinion? Are we on track? Are we on time? What is your perspective?
Well, speaking of being on time, I think we're getting close to the end of our webinar here, so I'll be brief. I think the pieces are in place from a technology point of view, from a motivation point of view, but ultimately it's going to need a combination of ingenuity, innovation, market-driven forces, because frankly, that's how things get done, is through entrepreneurs and people making things happen. With, as Julie's alluding to, the framework in which these things can operate, because frankly, that's how we got into the problem. We've got into this situation in the first place by, I think, excessive ability of the market to do things that are of value to individual companies, but from a societal point of view, haven't been so good. And so we've got to sort of factor that in.
Right. Peter, some last thoughts?
Yeah, I mean, I agree with a lot of what Julie said. I think very briefly, I think that there's a tremendous opportunity in recycling to kind of offset some of the environmental impact that mining will have. I think that there is a tremendous amount of material available, 500 million tons just in the US alone, where we can extract and harvest that material to produce what is driving the market, which is the neodymium magnet. And I think that there's a lot of optimism in the market for mining all the way through to metallization and magnet production outside of China to kind of support the demand growth. So I do, I guess, believe the supply chain is resilient and that it will respond.
The question is ICT technology, so that's 5G, quantum computing, and so on, if there could be a competitive demand against renewables deployment. So to say that renewables would be sidelined by other market demands.
I'm afraid that I still haven't captured it.
Oh, I think I captured it. Allow me to summarize. So the question is whether the projected demand increases for ICT technologies, right? Sophisticated computing and what have you, if that could potentially, threaten or sideline renewable energy applications.
I think it could. I mean, if I understood the question correctly, I mean, there are predictions that, for example, robotics or the demand for magnets in robotics will exceed what we see in wind turbine and in e-mobility by far by the 2050s. But of course, emerging technology will work against that. I don't know how magnet will look like in 2050. But I don't know if that was the core of the question. So it may also be a language issue.
Right.
Well, blockchain and mining and all of that, right?
Yeah.
This raises another coordination issue, particularly with the rise of cryptocurrencies and things like this, because even though these currencies are presented as being in the cloud, they have very heavy resource demands that overlap quite directly with renewable energy demands.
Yes, of course. I mean, data storage and blockchain is energy intensive, and we have to calculate very clearly if this is bringing a benefit or not. But we need some kind of traceability, and we need some kind of IP protection, and there must be a way somewhere in the middle of it. So now I got the question. Sorry about that.
Another question here, which I throw at all of you: what is the recycling rate of rare earths now, and how will it develop in the future?
I mean, there are different numbers around. I mean, a lot of people are talking about between 1% and 3%, others talking about 30%, but I think that what you target, I mean, if you look into production swarf, for example, it may be 30%, and these are massive numbers from slicing the magnets and bringing them into shape. But I think if you look into end products, it's somewhere between 1% and 3%. It's rising slowly, but as I said, the facilities and the sortings, and also the wish to recollect, and also then the sorting methods, they're just developing. So I think I would think something around 3%, not more, which is frightening less, or it's a pity if you look at other technology metals that have around 30%, like platinum or silver or so.
Gareth, here's a question that I think you should be the most qualified to answer. Mining carbonatites and focusing on TR&D or DY and TB raises the question: how do we avoid the overproduction of LA and CE how do we avoid that the overproduction of LA and CE is being used in a sustainable way? I think the question is simply the selective extraction. How far are we with that?
Yeah, so for example, there's well-known processes for peeling off cerium before you then do separation using conventional methods for rare earths. There's some work being done with respect to yttrium as well. If you've got a heavy rich deposit, they're typically very heavy in yttrium contents. The chemistry of rare earths, as we all know, are difficult and challenging. There is a fair amount of work underway and has been for some time for selective, plucking elements out of the rare earth soup. My evaluation of that to date is that there are some potential technologies or processes for doing that, but from a cost perspective, they're prohibitive. And so part of the solution is to find new uses for lanthanum and cerium, or increase the uses in different ways. They're used a little bit in magnets, as we know, to dilute the neodymium praseodymium to an extent, and there may be some other applications. But certainly from a mining beneficiation, those upstream processes, you can't avoid taking the bulk rare earths along with you.
Right. Another question for anyone who has an idea: how does China currently demonstrate traceability back to the mine site?
I'm very sorry, I have teaching obligations that begin in a couple of minutes, so I'm going to have to sign off.
Yeah.
But thank you all for the conversation, and I look forward to following up.
Okay, so does any of you have an idea about the traceability, the current traceability of China? No. Right. That's basically all the questions we have today. I think we covered a lot of subjects, but it is quite evident that China will remain the center of rare earth for quite some time to come, and that we will need a high level of international cooperation to meet our global warming targets. Yeah. Otherwise, the whole exercise may probably be in vain. Any last thoughts from you, Carlo?
Yeah, I would say we have the market need, we have the technology, and we have the will to increase the production, let's say the non-Chinese production. But as Gareth pointed out, sometimes the Chinese are painted as having captured the market. I mean, we've done a lot of things that China is dominating now, and I think they've just seen the potential much earlier than the rest of the world. And it's for us now to take this challenge and to catch up again, to have an equal level playing field. And for me, that's challenging, and that's great, and let's just do it.
Gareth, any last ideas?
No, I don't think I have anything to add to some of the great comments previously made. Thanks.
Okay. Peter?
I think I'll just say that I think China is very supportive of the growth that's happening outside of China. And I think that there's a great amount of technology that's being introduced, and the market is driving it forward. And I'm very optimistic about what's happening, especially from a recycling perspective, for obvious reasons.
Excellent. Very good. Well, thank you very much for participating in this panel. And I would like to now hand back to Florence Gomez for closing up of the session.
I just want to thank all the speakers, Thomas, the moderator, the panelists for taking part, and you, the participants. Of course, we had up to 70 participants today, a very international audience from, Australia, the US, a lot of European countries, Morocco, China, Japan, etc., which is fantastic. For some of you, it's very late. For some of you, it's very early. You will shortly receive a recording of this event on your email, as well as the presentations. We'll also be sharing them on our YouTube channel. Today, we had about 50% of the participants that are members. The others are not. We would be very happy to welcome you if you had any question around joining our organization. Our AGM for the members is going to take place on the 23rd of September at midday. And finally, I wanted to say that the question we raised today, how resilient is the rare earth global supply chain, actually led to covering an incredible number of topics, from standards and international cooperation to the fact that we need a more reliable and sustainable supply chain, to recycling, to production and transformation, market shares, legislation, etc. Pretty much each of these should be an event in itself. So we were planning actually for next year, and probably one before the end of this year, to organize events around standards and recycling and investments that we hardly touched upon today. Anyway, this is it for me. To those who do not follow us yet on LinkedIn or Twitter, please do so. Our accounts on both social networks is REIA, R-E-I-A. We have pretty much 500 followers on LinkedIn and want to double this figure by the end of this year. We're growing very fast. Thank you again for coming, and see you very, very soon at our next event, or for our members at the AGM. Bye.